Okay, so this is the TactionTablet in its final form. So we have the plotter mechanism on the XY axis down there, and that can move left and right along this piece of wood. And then you have the Y axis, which can move up and down along here. And through that, it can access every part of the grid. And so what we can do is, well, let's go through the electronics real quick, actually. So we have an Arduino Nano, which is a $3 part, and then two air conditioner stepper motors with driver, and those cost $1 each. And so the electronics on here are actually only $5 at this point. Oh, and then of course two of the $1 servos from Tower Pro in order to both poke the pins up and reset the grid. Solenoids ended up being too big and required me to use more power than I can get from a USB port, so I ditched those. But yeah, so there is firmware that I wrote that is running on the Arduino, and so that will go through a USB cable to your computer. And what that does is it just takes in coordinates. So if you say go to pin number, like on the grid, 1010, it'll move to pin 1010. And then if you tell it to move to 1020, it'll go to 1020. And in doing so, it'll take the most efficient and fastest path possible, which is really important because one of the biggest sacrifices of these stepper motors being so cheap is that they are slow. And so I've had trouble getting the pins correctly mapped to their XY positions. I figured that's like a relatively easy thing to do if you actually know software. I just don't, and so I'm going to have to consult Aaron on that, I think. But yeah, so let's give it a test. So this is a Python program I wrote real quick, and all it's doing is it's just sending a bunch of commands. So H means home, R means reset the grid, 2020 is a coordinate, so move to pin 2020, and then X is poke that pin up, then move to pin 2022, then X is poke that pin up, and so on and so forth. And you repeat that for this entire sequence. And then this just is code focus that sends it to the Arduino. And so all I have to do is tell it to start. And when I do, it'll first home the axes, which we're seeing now. And this goes particularly slow because I was able to do something really cool here. So rather than having it detect when it reaches 0, 0, it just runs the motor a little bit, turns it off, and then repeats that process. And so in doing so, it actually stretches the band ever so slightly, and then it retracts back. This means that you don't strain the motors, but you always end up at 0, 0 after you rotate it for the equivalent amount of moving it from this upper left corner. So now that it's done homing, it's using this stepper motor to reset the grid, and all of the pins are down. And now it's just going to start going through and poking up pins. And so it's not hitting the pins perfectly on the bottom. The bottom is designed to line up perfectly with one pin at a time, but it currently does not. And that is just due to my firmware not getting the positioning of each pin exactly right. Again, it's just a linear transformation that I'm not sure how to do in software. But you can see that it goes through pin by pin. Oh, come on. And pokes them up. And I can go and I can rub my finger all on them, give them nice taps, and they stay up. So now it's going to go back to, just do a little bit of a dance underneath there so I can feel what I want. And normally, of course, the computer would reset this automatically when you're done for the next image. Instead, I'm just having it move a bit and then reset it because programming in a delay ended up being too hard. And then, as you can see, they all just fell down. And from there, you can kind of do whatever. You can repeat the program, or change to a new image, or you can even take the tablet off of the top, which is a fairly interesting use case that I didn't expect to be so easy. But it just sits on here, and you can remove it. And it retains the image without that. And so you could take this somewhere and, do something with that, which is an interesting application that maybe is worth expanding on in the future. Anyway, I'm going to do another video real quick, just the demo again, but this time so you can see what's going on underneath. So it's homing. Again, just ramming it into the wall. But if you look really closely at these, well, you probably can't see it on the phone so well, but they're flickering on and off, which is it turning the motors on and off, moving them ever so slightly, turning them off so they have a chance to retract, and then repeating that. And so you can see we've lined up with 0, 0. Where it's touching those. The bearing is touching the wall. And then this is resetting the grid. Not that we care about that. And now it's just going along, poking. And if I had it lined up perfectly with each pin, you'd theoretically only have to poke once, but because it's not lined up perfectly, I figured more poking, more good. And so it's just moving around through its course. Again, that's just the course that I programmed, though. That should be generated programmatically. And then it moves. Just for the heck of it. And then he's supposed to be feeling. Whatever. Is there anything else I need to say? And then it resets the grid. Sometimes all the pins don't go down the first time, and so that's why it shakes itself a bunch. By shaking it like that, it makes sure that they all actually go down. Yeah, I don't know. Laser cutters are difficult. That's been the primary challenge here. I can only cut for about 20 minutes at a time, twice a day, because the laser tube gets really hot and then needs to cool down. I got a Craigslist mini fridge and drilled some holes in the side of it in order to try to make this process better of cooling my water for it, but it only does so much. There's a reason that the professional ones cost thousands and thousands of dollars. Anyway.